Understand addition theorem probability by using some examples. So we'll start with example 5. Example 5 in the book, it says that example 5. If probability that A can solve a question is 2 by 3, means PA is equal to 2 by 3, and that B can solve the same problem is 4 by 5. PB is equal to 4 by 5. Then what is the probability that none of them is able to solve the question? None of them is able to solve the question. So probability that A can solve the question is 2 by 3, means probability that he cannot solve a question is complement of A is equal to 1 by 3, 1 minus 2 by 3. Similarly, probability that B can solve a question is 4 by 5. That means probability that B cannot solve a question is equal to 1 by 5, 1 minus 4 by 5. What we need to find out, probability that neither A is able to solve nor B is able to solve, means intersection. Since A and B are independent event, hence their complement is also independent event. So A complement intersection B complement is equal to P A complement into P B complement, which in turn is equal to 1 by 3 into 1 by 5 or 1 by 15. So this is example number 5 in the book. Now let's see next example, that is example 6. Example 6 in the book says that the probability that A can solve a question is 2 by 3. Again the same information is given here. Probability that A can solve a question is equal to 2 by 3. While B can solve the same question is 4 by 5. Similar information. 4 by 5. If both of them attempted this question, then what is the probability that question is solved? So what is the probability that question is solved? We have already calculated that none of them is able to solve, which is equal to 1 by 15. What does it mean? That a problem is already solved means either A has solved or B has solved. Means complement of this particular thing. So answer is 1 minus 1 by 15. Probability that none of them is able to solve is 1 by 15. So 1 minus 1 by 15 is equal to 14 by 15. Means problem is either solved by A or solved by B or solved by both of them. That is 14 by 15. Now let's see the next example. Example 7 in the book. Example 7. If probability that A will pass the exam is 1 by 2, PA is equal to 1 by 2, B will pass the exam is 2 by 3, PB is equal to 2 by 3, and C will pass the exam is, there are 3 events here, 3 by 4. What is the probability that exactly one of them will pass the exam? Exactly one of them will pass the exam, means either A or B or C. Let's assume that A will pass the exam, means probability of A, and B failed the exam. B failed the exam means probability of B complement into and means fundamental principle of multiplication here. C also failed the exam, so C complement. In this case, we have assumed that A has passed the exam while B and C failed the exam. Or means again fundamental principle of summation here. Or only B has passed the exam, means in this case we are assuming that A has failed the exam and C has failed the exam, means complement of A and C. So in the first case we have assumed that A has passed the exam, in second case B has passed the exam. Now in third case, if C has passed the exam, it's probability of C, probability of A complement, probability of B complement. So probability of A is equal to 1 by 2, probability of B complement, we can find out complement here, PA dash is equal to 1 by 2, PB dash is equal to 1 by 3, 1 minus 2 by 3, and PC dash is equal to 1 by 4. So in this case, PA equal to 1 by 2, PB dash equal to 1 by 3, PC dash equal to 1 by 4. Plus PB is equal to 2 by 3, PA dash 1 by 2, PC dash 1 by 4. Plus PC is equal to 3 by 4 into PA dash is equal to 1 by 2 into PB dash equal to 1 by 3. So this is the required probability, and when we solve this one, we will get total 6 by 24. Or 1 by 4. So required probability is equal to 1 by 4.